Matrices. On the test, there will be some that I say you have to use matrices to solve, and you have to solve them by hand. Other ones will say use your calculator to solve it, and other ones are going to say use whatever method you want. All right. So you may want to re-examine substitution or elimination, because those could be good, quick ones, especially in specific cases. All right. This one says solve by using systems of matrices, and it says first by hand, and then you should check with your calculator. Practice checking with your calculator. Don't wait till test day to figure out how to use your calculator, because anytime I say you can use your calculator on matrices, it should be a correct answer. The only thing you can make a mistake on is interpreting it, right? If you had zeros across and you didn't realize that it was dependent, then you might get it wrong that way. Okay, so the first thing I need to do is I need to rewrite this as an augmented matrix. So my augmented matrix is going to be 1, -1 equals 2, and on the bottom it's 3, -1, 12. Now don't get in the habit of just doing this super quickly. Your variables have to match up, all right? And you have to count for things if they're missing. So if I had 3 equations, you have to count for missing items. This one's nice because our variables were already in order. I only have x's and y's, so it didn't take too much thought process. But do not fall in that trap of just writing every single number in order. Because if I had this y on the other side and you went 1, 2, -1, you'd have it wrong. Okay? So that means, real quick, that these are my x values and these are my y values, and the other side is what they're equal to. All right. The first thing I need to do is I need to work left to right. So I'm going to work with the very left column first. So in fact, this stuff almost disappears in my head. And I just focus on these two in the column. Well, the first one I'm going to focus on is which one needs to be 1. And that is our top one. That top left corner needs to be 1. It is already 1. That step is done. You don't have to rewrite it. All right, you don't have to say, well, I have to multiply the top row by 1. Well, that is done. It's already 1. So then I move down and say I need to make this 3, 0. I need to turn that 3 into a 0. Once again, let me just do this. Nope. Let's make that bigger. All I'm worried about right now is that 1 and 3. And I want to make that 3 into a 0. Now I can't just subtract 3, because you can't subtract 3 from every single element. Our equation would not stay balanced. But what I can do is I can add this 1 to 3. That's one thing I could possibly do. But 1 plus 3 is 4. That didn't help me. All right, what else I could do is I can multiply this 1 by a number, then add it to 3. Yeah. I would multiply this 1 by -3 and add it here. Well, what I do to one item of it, I have to do to them all. So I'm going to multiply this entire row by -3, take that and basically put it right on top and add them. All right, so multiply by 3, put it on top, and add each element. So that rewritten matrix, I circled this for a reason because I'm not going to change this at all. That's still going to remain 1, -1, 2, but just like Mike said, multiply the first row by -3, add that to the second row, and we're going to replace our second row with whatever we get there. All right, so -3 times 1 is -3. -3 plus 3, that's the 0 we wanted. But we have to continue going on. -3 times a -1 is a +3. +3 plus a -1 is going to be a +2. And finally, we have -3 times 2, which is a -6. -6 plus 12 is going to be a +6. All right, I am now done with this column. Nothing should change here. This is locked in. It should be 1, 0, all the way to the end. So then I go to the next row. And I ask myself, which of those needs to be 1? And which one needs to be 1? The -1 or the 2? Yeah, the 2. So I'm just going to focus on that first. We focus on our 1s first, and then we focus on our 0s secondly. So I need to change that 2 to a 1. Once again, that means I'm not doing anything to the top row. So I'm just going to rewrite the top row as 1, -1, 2. But my bottom row needs to be 1 there. Well, when I'm creating 1s, it's probably the easiest thing, so I just have to multiply by 1 half, because half of 2 is 1. So I'm just going to take half of row 2 is going to become my new row 2. Half of 0 is 0. Half of that 2 is 1. That's what we needed. And half of 6 is 3. All right, we're almost done. We just have to create a 0 there. Again, I don't care about anything else except for that -1 and that 1. Well, I could just add 1 straight to -1, so I don't even need to multiply this row by anything. I just add 1 to -1 to make it 0, which would be 3 plus 2 would give me 5. So my very last step, let's change that back to black. My very last step seems a bit big. My very last step is to change row 1, and we're going to do that by just doing row 2 plus row 1. We'll replace my row 1. 0 plus 1, still 1. 1 plus a -1 is 0. 3 plus 2 is 5. And the bottom stays the same. We have 0, 1, 3. So my final answer is x equals 5. Y equals 3. All right, make sure you know how to do these. All right, even though your calculator can do it, on the test, I will specifically say you have to use your hand. You can use your calculator to check it, but you will have to do these by hand. I'm not going to make you do a big 3x3 that takes half the class, but this you might have to do. All right, so moving on. So like I said, this lesson is going to go really, really quick as long as you know how to add and you know how to subtract. Okay, so when adding or subtracting matrices, the big thing you have to recognize is in order to add or subtract, our matrices must be the exact same size. It has to be. I made the must be the same for a reason. They must be the exact same size. So if I have a 2x3, the only thing I can add to a 2x3 matrix is another 2x3 matrix. Then we're just going to add the corresponding entries. So for example, we're going to do A plus B, where A is this matrix and B is the other matrix. So if A is -4, 3, 5, -2, that means this is a 2x2. In order to add these two, the other one must also be a 2x2, which it is. So just be on the lookout to make sure they're the same size. All right. Then all we have to do to add these is we're going to take corresponding elements. So if I'm in row 1, column 1, so that -4, I'm going to add that to row 1, column 1, 7. So our very first element is going to be -4 plus 7. Then we're going to move over and look at that 3. That's in my top right. So we're going to add that to the top right over there. So that's going to be 3 plus a -3. And then we just go down to that 5. Well, that 5 corresponds to that 2. It's in the same position. So that's going to be 5 plus 2. And our bottom right corner is a -2. Ooh, that's the same color. I already used green. What didn't I use? Red? -2 plus a -5. So this is just going to be 3, 0, 7, -7. And we are done. That's it. That is adding two matrices together. So the next one is A plus B. Are both those matrices the same size? Yep. So we can add them. So we're just going to do the 3 plus the 5. So I'm just going to kind of skip writing it down. 3 plus 5 is 8. So once again, I did the 3 and the 5. We're going to do the 4 minus the 4, which is 0. Let's change that color. Let's use light purple. So I did the 4 and the -4. Then we're going to do the -1 and the 1, which is also 0. And lastly, we're just going to do 5 plus 4 is going to equal 9. Pretty earth-shattering stuff, huh? Subtraction follows all the exact same rules. They must be the same size, and we're just going to use subtraction instead of addition. So if I'm doing a minus b, I'm going to go ahead and write out this whole thing again. So if I'm doing a minus b, I'm going to note that they're 1, 3, and the other one's 1, 3, so I can add them. So we're just going to do, let's highlight, I'm going to do the 3 minus that 3. So I have 3 minus 3 in my first one. Then we're going to do 5 minus a negative 1. So 5 minus a negative 1. And finally, we're going to do our 8 minus 6. So we're going to have 3 minus 3, which is 0. 5 plus 1 is going to be 6. 8 minus 6 is going to be 2, and that's it. All right, for C minus D, I have 3 rows, I got 1 column, I got 3 rows, I got 1 column. I can go ahead and add those. So C minus D, I'm just going to do this kind of in my head. I'll have negative 3 minus 4, which would give me a negative 7. I'll have 5 minus 7, which is a negative 2. And 6 minus 2, which is going to give me 4. So the negative 3 went with the 4. The 5 went with the 7. And finally, the 6 went with the 2. All right, that last one's A minus C. Well, that's easy enough. We'll just do, my first value in A is 3. So 3 minus a negative 3 is going to be a 6. 5 minus 5 is 0. And 8 minus 6 is 2. Yes?
Shouldn't they be the same shape?
Are you saying they have to be the same size for some reason? Are both those the same size? But they both have 3 elements in them. So let's look at A. A is, well, I'd call A 1 by 3, right? Would you agree with that? 1 row, 3 columns. Is C 1 by 3? It is what, in fact? It is, oh man, they're not the same size, are they? So if they're not the same size, I can't do any of this. So this is not possible. We have different sized matrices. One is a 1 by 3, one is a 3 by 1. It's impossible to do it. And one of your tip-off points was I kind of had to force the drawing. Which way would you draw it? Would you draw it vertical, or would you draw the answer horizontally? And if you come across that problem, it means that you can't add them. Because if you look at every other one of these, when they were the same size, and I add them, they ended up as the same size. Right? This was a 1 by 3. It ended as a 1 by 3. These both started as 2 by 2s, and our answer was a 2 by 2. I would have no idea what this answer would be if I add them. That's why it's not possible to add those. All right? They don't have corresponding elements. In fact, the only corresponding element that they have is the 3 and the negative 3, because those are technically in the same position. They're top left. But this is still in row 1, this is now in row 2, so they are not corresponding elements. Be on the lookout for those. Okay? Be on the lookout for ones that you can't add or subtract. That is in the homework. Alright, the last 2. These are pretty tricky concepts, so make sure you pay attention a lot. The additive inverse is the opposite of every entry. So if A equals this matrix with negative 1, 2, 0, 4, negative 3, 5, 2, 0, negative 9. My additive inverse, which the symbol for additive inverse is just negative a, would equal the opposite of every entry. So the opposite of every entry just means if it's negative 1, I'm just going to put a positive 1. If I have a positive 2, my additive inverse is going to be a negative 2. 0 doesn't have an inverse. 4 would be negative 4. Negative 3 is a positive 3. 5 is a negative 5. 2 is a negative 2. 0 is 0. And negative 9 is a positive 9. That is my additive inverse. It also says find your inverse and add it. Add it to the original matrix. So that would be A plus negative A. Did I miss a 0? Did I miss something, Rosie?
No, I just said it's not all.
It's all going to be 0. Yep, and in the homework it's going to ask for you to do this, but as long as you understand, you won't have to do every element. It's just, I created the additive inverse. Additive inverse means when I add it to each other, they turn to 0. So the only thing you have to recognize is how big this matrix is. It's a 3 by 3. So the end result is going to be a 3 by 3 matrix with zeros in it. Because negative 1 plus 1 is 0. 2 plus a negative 2 is 0. 0 plus 0. And we continue on. And we're just going to have a 3 by 3 matrix with just zeros. And this is called the 0 matrix. I know, it's a super creative name. That is called the 0 matrix. Just a matrix full of zeros. Okay, the last thing we're going to talk about is scalar multiplication. Scalar multiplication is distribute to every entry or every element. That's all scalar multiplication is. So if I have 3 times A, another way to write 3 times A is we can write 3 times the matrix, negative 2, 3, 5. So scalar multiplication is, I'm just going to multiply that 3 to every element. So that's just going to become 3 times negative 2. Then I'm going to have 3 times 3. I'm going to have 3 times 5. And that's just going to be the matrix, negative 6, 9, and 15. No, my matrix size does not change when I do scalar multiplication. So when I do addition, subtraction, or scalar multiplication, my matrix size does not change whatsoever. All right, my next one is negative 2 times B. Well, B is a 2 by 2, so let's just see how that looks. So if I have negative 2 times a 2 by 2 matrix, 3, 4, 2, negative 6, I'm still going to do the same thing. I'm going to distribute the 2 to every entry. All right, top, bottom, middle, wherever an entry is, you just have to multiply it by 2. So the scalar multiplication of this one is going to be 6, negative 8, negative 4, and a positive 12. All right, the last one is negative 1a. Well, that's just the additive inverse. I just distribute negative 1 to every single element. So if I'm doing the additive inverse of a, in other words, I'm multiplying every element by negative 1, it just turns into 2, negative 3, and negative 5. All right, now we get to the real hard stuff for today, okay? So hold on. Ready for it? Oh, we're done. Oh, it's just the homework. That's it.